So, hello again from my side as well. Welcome to my session about Quarkus and Spring Boot. If you were with my talk in the morning, you have seen a little bit about Quarkus already, but in this talk, I'll try to compare the two enterprise frameworks a little bit with each other. Firstly, a few words about me. I'm Dirk, I'm living in Bielefeld. There's our company, the headquarter, Gedoplan. I'm the CEO, and we are focusing on Java Enterprise, so J2E, Java E, Jakarta E, Spring Boot, since 1999, roughly. And well, I'm regularly a speaker on conferences and user groups, and there are some books and articles in Java Magazine and so on from me. So that should be enough about me. And let's go into our battle, or a little spoiler. Battle would normally mean would have a winner in the end, but that will be not the case. It's not the focus to find the best framework for everything, because that does not exist. So both frameworks have their pros and cons, and I will try to shed some light on how you develop applications with both frameworks, and what is your developer experience, what features roughly do you have, are they comparable, are they totally different, and in order to do that, we developed a little application. When I say we, that means that a colleague of mine, Hendrik Junich, and me myself, we developed the application, but he is doing a training now. He's leading a training, so he cannot attend here. Yeah, and it's a simple application, but not just a hello world. It should incorporate a complete enterprise stack. But to keep it simple, it's just about planets, the base data of planets, so the name and the mass, and we have some small service in it, so we can calculate the gravity between two planets in the end. But the logic is so small that everybody of us can understand that in a few minutes. So, and technical details, what did we want to have in the application? It should have some boundary for the user, so we choose a REST API, maybe including Open API. The URIs are shown on the right, 3 simple endpoints for retrieving all planets from the database, or adding planets, or getting the computed gravity between two planets. That should be enough. As database, we use Postgres, Hibernate, JPA, and well, the application should be in some kind externally configurable. We also made the gravity constant configurable. It's a constant, it's physical constant. You don't have to make that configurable, but just as a showcase. And then Hendrik had the idea to introduce a maintenance window. So by configuration, we can take the application down so it doesn't respond to the user. And that can be shown with external configurable configuration. We have health checks in there. Asking, is the database there? Is it okay? Can I connect the database? Or am I in or outside this maintenance window? And so on and so on. Metrics and integration tests. We'll, because we have not such long time, it's just 45 minutes. We will not have the chance to look into all of that. We have to make some choice there. But let's see how far we can go. And well, that's my slides. I have one additional after the demo, but now we're going into the IDE, and let's have a look how the application with the two frameworks can be developed. And let's start with Spring Boot. Spring Boot from the project setup is, we use Maven here, is made of several starters that are dependencies that you combine to have all the services in there that you want to have in your application, like support for REST or for database access and so on. And there is a plugin that is responsible for combining the application into a startable jar file, a fat jar if you want. So you can put that into production in the end if you want. And the application itself, the classes are quite simple. There is a simple entity for the planets. It gets its ID from a base class, ID is derived. I can just hop there. There's the idea. That's the base class. And then we have two additional simple attributes for name and mass and a constructor. And we are using Lombok here for the rest, just to keep it simple. I know that roughly 50% of you love Lombok and the other 50% hates it, but that's not the thing that we want to look at here. It's just to keep it simple here. So that's a normal JPA entity, nothing special here. And in order to access the database, we can use a repository, and that's one of the very cool points for Spring Boot. We can implement or we can define the repository just by writing an interface. It has to inherit from a base class from the framework, specifying which entity and which type of primary key or ID we have. And for all the standard CRUD methods like retrieve all entries from the database, retrieve one by primary key value, so ID, and many, many more, the base class just has that in it, or the base interface has that in it. And when the application starts, automatically by Spring Magic, there is an implementation built for you that implements that by using Entity Manager and so on. So you don't have to program that, and if you want, you can extend it by just declaring additional, for instance, finder methods, like the one that I show here in line 10. I don't use that in the application in the end. It's just for demoing how easy it is to have some additional database access methods there. It's just then magic happens from the method name, the keywords there, like find and by name or by, they trigger the construction of the method in the end. So that is a very simple possibility to extend your database layer by special finder methods, for instance. If that simple DSL that in the end the method names form isn't enough for you, you can even extend that or annotate that by a query string that should be applied then. So that's very cool. It's very simple, and that's it with our database access layer. And the REST API is a resource class here, which makes use of the repository. The repository is here, and the methods that expose the planets that we find from the database, either all or one of them, are then annotated with @getMapping and specifying the serialization method that you want to use. We use JSON here. And I would like to point out that this here is some kind of injection. Well, you won't see any injection annotation here, but I've placed a comment here below what is really happening. We use Lombok here to create a constructor that will take parameters for all the final attributes of the class that are the two planet services, planet repositories here. And that's, in the end, it's this constructor that is automatically constructed by Lombok. And you would normally annotate that with @AutoWired to make it the constructor that the framework should use when constructing objects of that type. And in Spring, you can spare out the annotation. You don't have to use that anymore to make it even more dense, your code. You don't have to use the injection annotation anymore if there's just one constructor. So the situation is clear. This constructor will be used. And if you are a fan of Lombok, you can do it that way. Just require args constructor and two final variables here. That's it. So the injection of the other services is done here by, well, two kinds of magic. Okay, and well, we specify parts of the REST URI with more annotations, and we will see similar things with Quarkus afterwards. So keep that in mind, how that is written here. In Quarkus it will be similar, but not totally equal. Okay, and well, there's this service that is injected here. That's this class here. And it makes use of the same technique, required args constructor and a final variable, replacing a AutoWired constructor again. And there is a injected configurable value injected from the environment. I come to that later on. So, and then what you need is one, well, it's a main class, that can be used to start the application, and its annotations lead to and the place where the class is in the class in the package path enable the application to find all the other components. So starting from that package onwards to sub packages, or the services that I've shown before are found when starting the application. So if I start this application now, run it just here in my IDE. I forgot something. I forgot to point out that we have an additional starter here in. To look it up. I don't find it now. We have a starter for the so-called dev tools in it. So the application monitors changes in the application. For instance, if I have a REST endpoint like this one here, where just hello is returned, if I request that endpoint by curl, for instance, I can just do that once. Oops. What have I done now? Greeting. Not hello, greeting. Okay, so with the answer hello, and if I change something in this endpoint, I'll switch to my run window before. If I change something here and save that, after some time, you can configure that time, the application will reload in the backend, and now reflect the new code that I've put in there. So if I use my curl now, we get the new value. But if you are too quick, so if I change something here, and then curl to quick or request to quick. We have the old version there. And there is some time in between where the application is down, because it's taken out of service and reloaded. And after that, we have the new version running. Yeah. So this dev mode is quite nice, but suffers from this polling mechanism and some downtime in the middle. Yeah. Okay, as I said, time's too short to show everything that we have in the application, but let's just have two details. The one with the configurable value. Yeah, this is IntelliJ magic here. The expression that is in the add value annotation is an expression that refers to a configurable value, g underscore const, and that can be specified in the application configuration, which is a YAML or properties file, where this const is in there. Again, it is not very sensible to define a physical constant as configurable value. It's just for demoing it here. If we would discover after 157 years of doing physics that the constant was wrong in the 70th decimal, then we could specify that as environment variable when starting the application and would use the corrected constant without redeploying our application. Yeah, so that would be the case. Okay, and the other thing, health checking. That is done by, thanks to Actuator. Actuator is another part of these starter things, where you can retrieve health checking or monitoring values from your application. And you can configure that where it will be exposed. We decided here just random that we use port 8081. So you can get health checking values from there, with curl, for instance. Could use health checking, for instance, for readiness, and have to scroll a little bit up, and we get a response with a status code of 200 if everything is okay, and a 503 if something is wrong. And that is a health checking possibility is just without programming it. If you want to program it, you can program additional checks. That is quite easily done. So that is a health check here. You have to just implement a component, a bean, implementing this interface, and then compute your readiness or liveness by specifying a health value. And I won't go into detail of this code here. You just compute an up or down there. And you can specify as many health check indicator classes as you wish, and they will combine by AND in the end. So if all those checks are up, then your overall status is up. If one is down, your overall status is down. So it's quite easy to extend your health checking with custom code, like our health checking maintenance window thing. What is automatically in the readiness checks is, for instance, checking the database. So that's part of the auto-configure magic of Spring Boot. If you use some database extension or starter, then you have automatically health checking for database connections in there. Okay, so let's turn to Quarkus. How would that be in Quarkus? The project that I show here is on GitHub. Yeah? You can check it out and try it out by yourself. The Spring Boot versus Quarkus project contains 2 sub-projects. Spring Boot, that is the one that I've shown here, and Quarkus, which I will go now into. Before I do that, I stop my Spring Boot application. So how does it look in comparison when doing the same thing in Quarkus? Well, first of all, the project setup is quite it's similar. You don't have starters, they are called extensions here, but it's the same idea. So you combine dependencies for the various sub-services that you need, REST API, database access via Hibernate, driver for the database, and so on. Health checking metrics, and so on. So that's roughly the same as in Spring Boot, and you also have a plugin that is responsible for generating the runnable application in the end. And the classes that we have in the application are also quite similar. So if we have a look at the entity class, it's nearly the same as we had that in Spring Boot. It's not exactly the same because I decided to show you one extension that Quarkus has, that is Panish. Panish is an extension of Hibernate, the Hibernate project, which gives you some kind of magic in the same way the Spring repository magic is there, not exactly the same. And you can decide if you want to have the database access methods in a separate repository, like I did that with Spring Boot, or if you want to have the methods in the entity class itself. So a rich entity, or however you would like to call that. And I decided to do the later thing. So I used will use the methods in the entity class itself. That is done by extending a class named Panish entity base that is from Panish. And that keeps, or that brings all the methods like find all or list all is named here, find by ID, persist, merge, and so weiter and so on in your entity class. We'll see that in the REST class, the endpoint class, resource class, how that is used. And as consequence, there's no repository class anymore. Every database access is in the entity class here. So let's go into the REST interface, resource class. If you compare that in mind with the resource class that we had in Spring Boot, it's quite similar. We have here also an annotation that spends some time or gives some part of the UI, and we have annotations that mark methods as get, post, delete, whatever methods. So it's nearly the same. There's a separate annotation for specifying the serialization method, but roughly the same as in Spring Boot. The difference, although, is that this is a standard. It's Jakarta RESTful Web Services, or JAX-RS, how it was called before the name change. So that is exactly the same code that you would have on some standard application server like Whitefly, OpenLiberty, and so on. No difference. Whereas the Spring Boot code is proprietary. It's just Spring Boot. Okay, and turning to the database access methods that we have in the entity now. Here you see how that is called. Yeah? So finder methods are typically implemented as static methods in the class, like list all, that is the find all method that we would have in Spring Boot. Or persist is the method in the object for the object that will store the object in the database as an insert. Yeah. So that's quite nice that you can do that with the entity class itself. Yeah. Turning to the injection methods, I used field injection here just to demo it. You can use instant variables annotated with @inject for that. @inject is the auto wired of Spring Boot for Jakarta E. Yeah, but you could as well, like I've done that in the Spring Boot application, instead of using field injection, you could use a constructor as well. Yeah. So that's exactly the same. If you want to use constructor injection, do it. Yeah, it's the same. You have the same possibilities in Quarkus and in Spring Boot. Of course, I could do the same magic for with Lombok here as I did that in the Spring Boot application as well. So it's the same. And what is also the same, you can ignore or leave out the @inject annotation. In Quarkus, it's possible, as it was in Spring Boot, if you have just one constructor, then this constructor will be used for constructing the objects, and the parameters are injected there. Yeah, so it's exactly the same like in Spring Boot, but that would be non-standard. So if you would have to like to have portable program code that can be deployed onto some standard application server, that would work only if you use @inject. Yeah. So back to the original with the field injection. Okay. Yeah, there's the service that we had before. That's nearly the same as we had that in Spring Boot. The configurable constant here is injected by means of @config property. So there's no @value with a expression language, is just referencing a single value here. But if you want to have some expressions, like you could do that in Spring Boot with this expression language, that can be done in the configuration of this variable here. Yeah, so that is utilizing microprofile-config, and microprofile-config uses expressions in the definition if you want to have that there. Yeah, and here also @inject can be left out, because if you have some qualifier, that's a qualifier in terms of the standard CDI specification, then Quarkus will use that as in the injection target, regardless of you specifying @inject or not. Yeah, so the same idea as @autowired or @inject on the constructor is used here for injection of configurable values. Okay, so let's start the application, or build it and start it. That would be done by just Maven with the help of the plugin that is in Maven. So let's do that in Quarkus, and that's am I in the right directory? Yeah. Okay. So a Maven package, for instance, will build the application and package it. And the first things that run now are just normal Maven building steps. And in the end, that is now the case. The plugin for Quarkus takes the compiled application and builds a runnable thing out of it. Yeah, the runnable thing is a directory, Quarkus-app, in the target directory, where the application resides in a directory named app. The dependencies are in lib, And then Quarkus does some magic at build time. The association of injectable resources and injection targets, for instance, is done at build time, other than in standard JEE or even in Spring Boot, that is done at runtime by a reflection. But the association of injection targets, observers, and so on is static. So all the knowledge is at build time, and Quarkus utilizes that. And it generates, I call it glue code, that is placed in this Quarkus directory here. And the Quarkus -run jar file, which is very tiny, just 651 bytes long, that's just a starter, a main class, if you wish, with class bus dependencies. So, and we start that with Java -jar and start this jar file there, and that starts the application in relative in just a few seconds. 2.5 seconds I've used here. If you have that in your mind from Spring Boot, that would be 6-7 seconds. So Quarkus is a little bit faster at start. That's because this build time optimization took place while build time. Build time is a little bit longer, and starting the application is faster. So the application is running here. We could use that for storing and retrieving planets from there. If you want to try that out with the sample project, there are some shell scripts that you can use. It's just wrappers around curl. So we can post some planets into the database with a post script. The post script, I can show it how that is set up. That's just a sequence of some curl commands that post our planets of our solar system into the database, and now we can retrieve them with a similar curl script. I've done some predictability here, so the entries come now from the database, stored in the Postgres database now. Okay. Another thing that is quite nice, I showed the dev tools in Spring Boot. A similar thing is available for Quarkus. Quarkus has a dev mode that you start typically with Maven. There are other means that you would do that, but this plugin Quarkus has a goal dev, and that can be used to start the application in dev mode. And when it is up and running, which is now the case, it takes a little bit longer because it's just a build cycle. And well, there was a different thing I would like to point out in a few minutes that makes it start a little bit longer, but that runs in the background now. And if I change something in my code, like I've done that with Spring Boot before, that will also lead to some kind of reloading, but not now where I've stored that. So the change in the source code has been stored in the file, but Quarkus dev mode doesn't react now. But if I curl to the endpoint, one of the endpoints, so for instance, my greeting endpoint, my hello greeting endpoint, now the hot reloading takes place in the background. So hot reloading is now not triggered by some polling mechanism that scans your code every so and so seconds, but when I do some external request, like a REST call, or if you had a website request to the website or something else, that triggers the reload, and the application or your client is blocked for that time, so you have no chance to request some status of your application that is not the case anymore. Yeah, there's no downtime where you get some 404 code. You just wait for the reload to take place in the background. And the reload took under 1 second. That's due to a configuration that I made for my Quarkus application. There is a property that you can spend for defining how the class reloading should take place. If you change a class just in the code and do not add any methods or method parameters or so on, then the class can be exchanged without reloading the whole application. That's done by instrumentation. It's the same technique that you know from zero turnaround with JAVAPRO, for instance. Yeah, so you can enable that for Quarkus, but Quarkus has a fallback. If the instrumentation reload does not work because you change something in the interface of your classes, then the whole application will be reloaded. So you have both methods in place. Yeah. Okay. We had a look at the configurable values in Spring Boot. It's nearly the same in Quarkus. The definition of default values can take place in the application configuration, this properties file, or if you want to have a YAML file, that would be feasible as well. And you consume those values in your classes by injection with config property. That's a qualifier for that. We saw that just before. And changes of these configuration are also reflected by reloading. Yeah. So if we had a look at the health checking endpoint that is also in Quarkus here, that makes use of injected values here for the maintenance window. And if we are in the maintenance window, the application should respond with a I am down if I request the liveness endpoint. Yeah, and the configuration for health checking for the maintenance window is well, from 13:30, 1 hour. So we are not in the window now. So if I go to the health checking endpoint, which is the Q health ready endpoint, that tells me I'm not in the maintenance window because we are out of this 1 hour period starting from 1:30. But if I change that here and say, well, 14:30 and curl to that endpoint, hot reloading takes place in the background, and now the application is down. Yeah, overall status is then down also, which is reflected with the status code 503 then. Yeah. So also not only class changes, but also configuration changes trigger the reloading of the application in the backend. Okay, time is short, so let's have a look at one additional thing, that is testing. Testing in enterprise applications is quite difficult normally because you have to control the application lifecycle. Yeah? So when running a test, the application first has to be started, or if you have an application server, the server has to be started and the application has to be deployed. Then the integration test runs, and after that, the application is undeployed and the server is stopped. Yeah. So with regard to our applications here in Quarkus or Spring Boot, first the application has to be started, then the test code is run, then the application is taken down again. Yeah. And that is possible in Quarkus with a single annotation. it's nearly the same as in Spring Boot. In Spring Boot, if we had test there, or if I had shown you the test there annotated with a Spring Boot test. Here it's Quarkus test. Yeah. Okay, I think they have looked each other up. Yeah. And at Quarkus test is a test extension for JUnit 5, which makes a unit test written in JUnit 5 into an integration test. Yeah, so we start the application first, then we have injectable objects here. We can use @inject to inject objects from the running application into our test class in order to make white box tests, so call methods in the application and check the results and so on. Or we could also use black box tests where we use some external call framework, like a REST framework for calling or REST API. Yeah. Quarkus comes easily with REST assured. This is one of the test frameworks that calling client frameworks that you have for REST, but it's not limited to that. You can use either or any test framework that you want to have. And if I run one of those tests, then another instance of my application is started, and it doesn't collide with the running dev mode application that I have already running. So it uses different ports and it uses a different database. And that leads to one thing that I would like to point out in my application configuration. I had database connections specified for just the prod mode. That's this prefix here. This is a so-called configuration profile. And the prod mode is active only if I start the application by Java -jar and then the jar file. So the first starting method that I used before, but not in dev mode. In dev mode, we have no database connection configuration here. That would be the prefix %def. And the extension for Postgres, and that is the case for other databases as well, contains some auto configuration which spawns up a database in a container if you don't specify some valid or some connection details for your database. So Quarkus makes use of the technique that you probably know from test containers for giving you all the subsystems that you need for development. And in test mode, we have a separate instance for the database. So my tests run against a different database. It's not the same that I have in my dev mode. And last thing, very cool, I think, is if we turn to our running application here in dev mode, we can even enable the tests there. Yeah, it's just a shortcut here. You could enable them by default. And now tests are run in the dev mode, in this window. In your normal development environment, you might have a separate monitor for that. So you have that always in you can watch it all the time. And if it's green, everything is okay. If it's red, you have broken something. Yeah. So if I, for instance, change my Planet service to compute here something wrong, then the tests that depend on this change will be rerun. My application contains 2 tests, but only one is dependent on the service, and only this one is run, because the plugin has some run path analysis done, so it's clear which tests have to be run if you change some part of your code. So in the end, in a real life project, you have hundreds of tests, but only the ones that are affected by your current changes are run. That's totally cool. Yeah. And I correct that again, and now everything is green again. Yeah. So that's quite convenient. It enhances my developer experience. Everything is so quick. And I have tests running all the time, continuous testing. I have these dev services, so these databases running in containers. And that's not database alone. It's also messaging brokers or identity providers like Keycloak that can be used as dev services. Everything is so quick, so nice, so agile. Yeah. Okay, my time is running out, so let's turn to my last slide. Developer experience is one thing, but what is the fact of the readings and measurements in production in the end? How fast is the application? How long does it take from starting the application to the first response to some REST call, for instance? And I've measured the times of the Spring Boot application and the Quarkus application on my machine here. So the absolute numbers are, they will vary on your machine, but the relative numbers are interesting. And the time to first response in Quarkus is way shorter than you have that in normal conditions. Yeah. Also, the executable size is less than standard EE stacks. That's because the plugin is able to mark code which is not reachable and that is not loaded. Yeah. That's not in the Quarkus app directory, and it's not loaded in your runtime. So memory consumption is also less. Yeah. That's quite interesting if you go to the cloud and pay for every byte that you use. Yeah. Okay, that's it from my side. The project is on GitHub. You can check it out from there and play around with it a little bit. Yeah. Any questions? Do you have time for questions? A few minutes. Maybe.
Yes, we can wait a few minutes for some questions. I'm also gonna check the chat.
There seems to be no question. You said earlier there's no winner, but I think we clearly have a winner here. Well, it's a little bit opinionated. I find I'm a fan of Quarkus. It's really cool, but I, as a consultant, would not advise my customers to migrate all their applications from Spring Boot to Quarkus. That's nonsense. It introduces costs and risks. You won't do that. But if you have a free choice, then maybe Quarkus is more interesting. Or if you have a deep and working and long knowledge of JEE, Jakarta E, Java E, or so on, then you don't have to think in different frameworks. You can stay with your code. That's interesting. And then Quarkus is the winner. If you have done Spring for many, many years, you will stay with Spring. That's totally okay. Both are good. Yeah.
Okay, thank you. There was another question. Could you explain the scopes in Quarkus, like application scope?
Yeah, application scope like this here is a declarative means of making a singleton. Yeah, so the framework will instantiate just one instance of Planet Service, for instance, and most of our infrastructure services that make up our application, so computations, database access, and so on, you normally just need one object for that, and it's just one application, one annotation to make this class a singleton. That's it. But there are other scopes. If you want to have a class for every request, for instance, if you want to have a class, an object for every REST request that you make, you could use request scope for that. Yeah, it depends if you have some data in your class that change from request to request. Yeah, if that is not the case, and most of the time it's not the case, application scope is the best scope. Yeah.
Okay, so there are a few more questions.
Yeah.
Are the numbers you've shown from native builds or with JVM? Would be interested in the difference as well.
Yeah, the numbers that I showed were JVM numbers. It's not native. Yeah, if you can compile Quarkus applications into native code, then the numbers will drastically be reduced. Yeah, you have starting times around some 50 milliseconds or so. Yeah, and memory consumption will be less. But you always have to keep in mind that a JVM running application can optimize itself while running. So native applications are interesting if you have short running applications. Yeah, like command line tools, serverless applications that should spin up in no time and will be scaled down to zero after they've done their thing in a few seconds. Then serverless, then native applications is a cool thing. If you have a classic server application that runs for some time, then a JVM based application in the end wins. Yeah. But the numbers that I showed were from JVM. Yeah.
Okay, unfortunately, we are running out of time, but maybe we can answer like one or two more questions. So what is your opinion to Micronaut and Helodion?
I don't know both frameworks in detail, but there are a possible choice as well. But market share is comparably low. Yeah, so the leader in those enterprise frameworks in respect of market share is Spring Boot. Roughly 70% of applications in that scope are done with Spring Boot. And Quarkus keeps up to roughly 26, 27%. And the others, they have below 10% market share. Yeah, that may change in the future. Yeah, it's just a snapshot now. But taking that into account, my choice would be one of the big players. Yeah. And what is for me is very interesting for Quarkus, that is standard code. You have Jakarta E code in most of the places. Yeah. You can leave out the injection annotations or so on, but that's minor changes. In general, you have standard applications that could have been used on some standard application server before. Yeah. So if I come from that knowledge or software, then Quarkus is my best choice.